In this video, we'll talk about how to simplify an algebraic expression by combining like terms. So let's make sure we understand the words that we're using here. So what is a term? In an algebraic expression, a term is a product of numbers and variables. So there's lots of different examples I could give. So for example, 3x is a term. So the number here is 3 and the variable is x. A number all by itself, for example 10, is also a term. So you don't have to have any variables for it to be a term. You don't have to have any numbers either, just y by itself is also a term. We can also have multiple variables, so you could have 5xy. That's also a term. So the number is 5 and we have variables x and y. We could have the same variable multiple times, so we could have 4 times x, which we would typically write as 4x squared. So that's also a term, a product of numbers and variables. The number could be negative, so negative 6 times xyz is also a term. So as you can see, terms come in various shapes and sizes. We already saw this a little bit, but sometimes the same term can be written in different ways. Let's take a look at the term 6x squared y. So what this really means is 6 times x times y. We have x twice because we have x squared, and x squared means x times x. But we can rearrange those 4 individual pieces, 6, the 2 x's, and the y, we can arrange those in any order we like. So we could write this as x times y times 6 times x, or y times 6 times x, etc. So we can arrange them however we want. Now typically when we write a term, we always write the number in front. We always write the 6 first. But then we could also rearrange, we could write this as 6yx squared. That would be a perfectly reasonable way to write this term. You probably wouldn't see this written as 6 times x times y times x. So we, again, usually don't split up copies of the same variable. That would just be a confusing way to write this. We would always want to rearrange and put the x's together. But again, why would we write it as x times x? The most simple way to write this would be 6x squared y. So you can see the same term written in different ways, but really the only way that we would sort of normally see this term written would be as either 6yx squared or 6x squared y. By default, we typically write the variables that we see in alphabetical order, so it's more likely that you would see this as 6x squared y rather than 6yx squared, but that's not a rule. We don't have to write the variables in alphabetical order. All of these things that I've written on this slide are all valid, mathematically correct ways to write this term, but you'll just typically see it in one of the 2 ways that I've circled here in blue. Okay, so what are like terms? Well, 2 terms are like terms if they contain the same variables raised to the same powers. So to see if 2 terms are like terms, we don't pay any attention to the number that might be there. We only pay attention to the variables, and it has to be the exact same variables to the exact same powers. So how would we combine like terms? So if we had this algebraic expression, the task that you would be given would be to simplify this algebraic expression. So what we're looking for are like terms. So we could start with our first term here, 4x, and we want to say, okay, what are the terms that are like terms to that 4x? So we're looking for terms that have just a single x and nothing else. So 6y, that doesn't work. So this is not a like term. 8xy, well that has an x, but it also has a y, so that's also not a like term. Minus 2y, well that doesn't have an x in it. 4x, oh that's a like term because it has an x just like the term that I have in the front. So that is also a like term. And then I've got yx, that doesn't fit, that has a y in it. 5x squared, that just has x, but it has x twice, so that's not a like term either. And then finally we have y, which again doesn't fit. So what would be a like term to my next term, 6y? So there I'm looking for terms that just have a y and nothing else. So that's a like term, 2y, and then this y at the end is also a like term. Next up I've got 8xy. So to find a like term there, I'd be looking for a term that has x and y. Now yx doesn't look like the same thing, but remember that the same term can be written in different ways. So that yx can be rearranged as xy, and so that is a like term. And then finally, the only term we have left is 5x squared, and that doesn't have any terms that are like it, so that's just all by itself. Now, how do we combine these like terms? So we're going to take the terms that were like terms. In this case, I've got 4x and then minus 4x. And when I take 4x minus 4x, well, those just cancel out and I just get 0. Next up, I've got my y terms. So I have 6y minus 2y and then plus y. So 6y minus 2y plus y. And the way that we combine like terms is we add or subtract as necessary, as the operations dictate, the coefficients. So in this case, we get 6 minus 2 plus. Now, there isn't a number in front of that y all by itself, but that just means that there's one copy of y. So I could think of that y by itself as really being 1 times y, because multiplying by 1 doesn't actually change the value of an expression. So combining those terms, I combine them by adding and subtracting the coefficients. So 6y minus 2y plus 1y is 6 minus 2 plus 1y. 6 minus 2 is 4, 4 plus 1 is 5, so this simplifies to 5y. Next up, I've got my green terms here, so 8xy and yx, 8xy plus yx. To make these look more like terms, I'm going to rearrange the yx as xy. Again, I've got a assumed 1 there, so because there's not a coefficient in front of the xy, there's an assumed 1 coefficient. So then I add the coefficients together, 8 plus 1 times xy, and 8 plus 1 is 9, so 9xy. And then finally, the 5x squared, since that's all by itself, I don't have to have anything to combine it with, so I just leave it as the 5x squared. So when I combine these terms together, I've got 0, which doesn't do anything. If I add 0, nothing changes, so I ignore that. So I get 5y plus 9xy plus 5x squared. And that's my simplified expression. Sometimes we have a little bit of work to do before we can combine like terms. So in this case, we've got to distribute the multiplications that we see here. 3 times x plus 2, that means we have to multiply 3 times x and 3 times 2. Minus 4x times x means we have to multiply the minus 4x by the x and by the minus 6. So we get 3 times x plus 3 times 2 minus 4x times x minus 4x times minus 6. Simplifying those products, I get 3x plus 6 minus 4x squared. Minus a minus is a plus 24x. Now, when we go to combine like terms, we actually see that there's only one pair of like terms. The 3x and the 24x are my only like terms here. So when I add those together, I get 3x plus 24x gives me 27x, because I add the 3 and the 24. So my final simplified expression is 27x plus 6 minus 4x squared. And that's a perfectly valid answer to this question. It's typically not the way that you would see this written, because usually when we have expressions like this, we write them in order from the highest power down to the lowest power. So I would typically write this with a minus 4x squared first, and then the plus 27x, and then the plus 6. So this is not incorrect, but it's just not how you would typically see it written. So that's how we combine like terms and simplify algebraic expressions.